All right. So the September edition of the Web Native File System community call. We may have some other people filter in, we'll see. But as now everyone but Brendan has heard my speech on this, I'll just round it out. Apparently it's a holiday in like big parts of Europe and Brazil. So it might just be us. We'll see. We'll see who shows up. But that's not entirely a terrible thing. It means we can go deep on some stuff or have a short call. Either's fine. Yeah. So I guess I'll start with a bit of an update on where things are at and kind of what we've been poking around with. So the Rust WASMification of Web Native continues to chug along, which is great. It's about to go behind a feature flag in the Web Native SDK for the WASM stuff, so that you can then, when you load it up in a browser, say, like WASM:true or something, and it'll switch to the new version. It's not a feature parity yet, so it's like not really meant for, production use, but it'll be usable so that people can play around with it. The high-level interface is the same. It's just all of the internals are different and some of the data structures are different. So it's not like a one-to-one equivalence, right? Yeah, so actually, technically, the public side is already like that. This is wrapping up the private side. And then we've also been looking at accumulators. So replacing name filters with cryptographic accumulators, which has been a journey of figuring out which of these actually would meet our needs. We've had this penciled in as like we'll probably need to switch to these at some point for like 2 years, and it's kind of like, this is the point where we need to actually go and look at them. Here's the following problems with accumulators. There are no high quality libraries that are already another one. No high quality libraries that are already audited, like formally audited, etc. Most of them, as far as I can tell, have some performance downside. So we were playing with the ECC-ACC library a week or two ago, and it has exponential prover growth. So you prove it based on the size of the elements in the set. So a cryptographic accumulator, essentially, you have a bunch of elements in the set, and you can add more to the set, over time, and you get what from the outside just looks like random bits, but then you can prove that certain elements are in the set, right? So on a single element, it takes 73 milliseconds. On 20 elements, it blew through all the RAM on my computer and crashed Node, right? So we can't use that one. But they all have like, all these different techniques have slight different ways of working. So we're currently in a search for one that would be, in an ideal world, it does all of these things, but I think something's gonna have to give. Small accumulator, small proofs, or small witnesses, I guess is the term. Fast to prove, fast to verify without needing to a private key, right? If you give somebody the private key, they can usually reverse it immediately. It's very, very fast. But then they can also prove literally anything. They can just like construct an accumulator that does whatever you want, right? So there's also some newer techniques, some of which are actually literally out of Protocol Labs, that have no implementation and they're just papers. So sounds less useful in September of 2022, right? It's like, okay, we could implement something from a paper and like hope that we did it right, and it uses Kate commitments, which none of us on my team like actually understand, how that works in a deep level, right? So it's like one of these things where it's like we're not, cryptographers. We're building all of the other hard parts out of cryptography, right? So that's kind of where the accumulators stand right now. It's possible that we just the name filters as they currently are, technically, like their class as a kind of cryptographic accumulator. We may just make them like much bigger, and then that also solves the same problem. It's just we would need them to be about 5 to 10 times the size, which kind of sucks. So Yeah, and then next up on the backlog is, and would actually love to hear if people have, I know at least 2 people on this call have use cases for this, right? I'd love to hear like where in the priority stack it would be, is linked data files, or as Brendan used to call them, LD files. And so that we can then break up like subfiles and do structural sharing within those. Actually, I don't think that's too difficult. It's probably like, you know, 1 sprint or, you know, a week or 2's worth of work, probably to like actually do that. But it just adds some extra complexity to the merge algorithms, right? So yeah, so let me just check my list here. Is that everything? WASM accumulators, LD files. Hey, I did it all from memory. Amazing. So yeah, I'd love to hear if anybody has thoughts on LD files or any of the other things, or kind of open it up to all of you.
Can you explain quickly what the LD file stuff is?
Yeah, absolutely. Sorry, this is probably a good idea. So in, obviously we use a lot of structural sharing in WNFS. And you may have a file that is, say, structured JSON, right? And there's some sub portion of it that is not going to change between revisions. So you just want to change, you know, some metadata, but not like, you know, let's say some nested object, or maybe an inline photo or something in here, right? There's been a feature request to essentially break those up. So still have it be one file, give it the same I number, right? But then as you change revisions, it should be able to point and have a pointer at the old CID for that one shared subcomponent of the file. So in the same way that we can break things up into blocks at arbitrary breakpoints, this gives people control over like where that break would happen, and also nesting. So you could say, I have a linked list, and I'm only going to add things to the head of it. And so I'm just going to always reference the new one from, you know, all these later revisions, and then I can play back and forth over time on that. So we get, especially if you have like more granular data, this can be useful. And so both for space, you're again sharing some of that structure, but also so that you can just do really fast writes. Just like, I'm just going to update this one field and then point to, you know, the rest of this substructure of some kind.
Okay, I see. Yeah.
Yeah.
So you do that at the data model level.
And yeah, exactly. Yeah. They get broken out into blocks. Yeah. Okay. Yeah. So the layout today is every node, every revision, right, has it's a multi-value. Sorry, this is on the private side. You can also think about this on the public side, but I think on the private side, it's like clearer why this needs a little bit of thought before we just dive into it. You can have multiple versions because of concurrent edits. And so they'll say like, yeah, version 5 of this file, here's the 5, you know, here's 2 different concurrent writes of that. And if we want to break that up even further, we probably can just toss them all into that same place and then have some, you know, in the header say, you know, look here for the top of these files, and then look inside. There's also a version where they end up just generally in the tree, and so they end up getting pulled out of that that leaf and get given their own leaves, basically. But then you have to go hunting around in this HAMT for the other parts. So there's a little bit of complexity in there. Mostly it's just a question of like, we have to make some decisions about how it'll get designed. I don't think that is rocket science, it's just we have to do it.
Okay, yeah. Okay, that could be relevant to what I need. So, because I don't know if you remember, I basically want to store resources that can have multiple representation for the same resource, like think about the contact. It will have like a JSON representation, and it will also have a photo and maybe a vCard representation. And these are it's the same resource with different views, kind of. And like if you update the name of your contact, you will update the vCard, but not the photo. And so something like that could be a good fit too. Yeah, for me. Yeah. Okay.
Yeah.
Awesome.
Can I jump in? Okay, Brooke.
Please. Yeah.
Yeah, one of the original design intents was to provide a file type that is specific to structured data to facilitate some of this conversation, right? Like if the file system is actually aware there are files, there are directory files, and then there are structured data files. And as Brooke pointed out, that creates complications at the merge semantics level, not just in terms of how do you merge two structured things, but now you have an extra branching factor to take care of at every point of comparison. The LD file gives you this, like, would give exactly that, like the WNFS v2 spike we wrote in Go. Like if you gave it JSON, it would serialize that to CBOR, but by default, so it would do CBOR under the hood for storage, but a JSON view effectively when you were looking at it from a file system perspective. And so it was just like, which exactly maps to the CBOR diagnostic representation, which is just JSON. And so like you can do stuff like that in ways that are useful. It can get really messy and application specific, but I think like if WNFS has these things, we can sort of expose a more sophisticated interface that can be opt-inable. It's everybody knows files, directories, files, cool. But then we can optionally open up this automatic behaviors. Like I've made the WNFS CLI tool that we worked on, like just cool. If you give it a file that ends in .json, it just does this thing automatically for you. Some of the questions I have on that, like, I think one of the big challenges that we run into is like, or one of the advantages of the file system approach is not having to think about the block limit. And so like, I think there's, you know, can we live in a world where WNFS just automatically handles, you've given me a map, like a subsection of this that happens to be 25 megabytes worth of data. It's just auto chunked for you. And so that may actually be a DAG of representation. But from the perspective of like the data layout, like as long as if the end user of this, if the WNFS user space does not force users to think about block limits, I think that really provides a massive win, where it's just like, I can just throw structured data at this thing. And I have a heuristic in specific context for being able to lay my data out and actually inject certain breakpoints that will make the versioning cleaner. I think that's the real, that was why I thought it was justifiable to even wander into this space when we so clearly have IPLD and we so clearly have UnixFS. And this is very much taking the UnixFS world and trying to do an IPLD-like thing without going all the way into the full IPLD universe. So for me, that's my biggest question is just, can we code it up such that if I hand structured data whose serialized representation is greater than a block, well, can WNFS just chunk that for me and deal with it?
Yeah, so I don't see why we couldn't see that in like the like with some naive algorithm that just says, okay, this is 50 megs, you're structured roughly like this. You know, I'm going to take anything that's like really long, shard it, you know, anything that's really deep, break those into blocks, right? All of that stuff. I guess less, other than the fact that it's nice that you get, you know, exact chunks of data coming back at you, and maybe even, you know, turning all of the keys, you know, the key values, right? All of the keys into links, and like you can even go like really granular with this, right? The merge stuff, I think, is where that gets harder, right? For sure. So if you look at both, I guess there's 3 systems. There's more, but there's three that I'll cite here. YJS, AutoMerge, and Dialog all try to solve this problem for concurrent writes. So the level of granularity, having something application specific absolutely makes sense, right? It's like, I know in my application, these are the chunks that make sense to live together. And that also means that like the level of atomicity also stays together, right? It's like this object has to get updated all together, because if you merge, just the fields in them, you're going to get something that doesn't make sense, right? Great, totally. And in something like WNFS, you can have that be way more automatic than in something like Dialog, where you have to write a Dialog query to know how to do the merge, right? I like the idea of it being automatic for sure, and then giving people plugs into it. Absolutely. Something else that we've been playing around with, and this does relate directly, and that we talked about in Reykjavik, is a lot of the design decisions from existing things try to minimize the number of links because they're trying to move stuff over bit-swap. And so there's all these network layer considerations that happen. And when we don't have to worry about that at all, like, yeah, you have to follow this extra link. You've got to go into your store again. And that's not free, right? You have to go find this thing in a big table, but it's fast, We can make that pretty granular. And if we're packaging things up and then sending over the wire for when we're sending things over the wire, I think that we can then separate these concerns out and actually get pretty granular with data. So maybe just toss it back to you, Brendan. How granular would you want this? Like, obviously giving people the ability to adjust to this, but like as a default for JSON, would you want something that is like literally DAG JSON, every key is its own link, and every value is another block with the overhead that includes? Or like how would you go about automatically breaking up, say, JSON, for example?
Yeah, I mean, I think, before even answering that question, I'd back up, because I think if you look at some of the use cases that motivated this, I'm like not actually, you'd articulated in like, I'm going to use it just for the crude terming, like the Brook version of LD files and the Brendan version of LD files. In the Brook version, you have this capacity to do really neat stuff with semantics and links and actual data layout work. In the Brendan version, it's far more stupid, where like the linking is not really. I can just hand you structured data, and the awareness of structured data. WNFS is aware that data is structured and can do more magical things, because there was an automatic pickup moment, like views in my mind. I think Fabrice and I are really, I'm not going to pigeonhole you for Fabrice, but like I think that getting at a similar idea of like structured data is kind of different, in terms of the actual, something that we're finding a bunch in our research is like commingling data with links creates real parsing speed problems. And that's where, like, when we talked about a number of the refactorings that happened instead of WNFS header blocks, where we actually pulled out, there's a block that points at user land data, and then WNFS header blocks actually contain all of the links you need to actually be able to traverse stuff. Aside from the links inside of the user land data, which is, consider that a separate concern for a moment. That's like, you can write a parser that is much faster, right? And you can also do some really cool stuff where you like just don't fetch content, just lazily fetch headers and lazily fetch content, which is really nice no matter what sync protocol you write. Just being able to do being able to do stat operations that don't actually touch any data over the wire is like, in my mind, one of the huge wins that you get out of the overhead of introducing a new block, which is the header block, over the traditional system. And so dropping that back down a layer to like, how granular do you want it? Yeah, I think it'd be really cool if there's a super low level API that allowed me to tune this kind of thing and like lay it out. I would expect that's like wicked smart, like application developer land, where they're like really going deep and saying, I want WNFS, but like I want to be really fancy and particular about it. But to your point around having a nice, happy automatic path, like the view that I have in my mind is just like, I can throw a specific class of either runtime serialized data. I can just say smash into file, and I'm an application developer, and I'm like, this is my, Go map struct interface of whatever. And I can just give that to WNFS and be like, cool, I got you. I'm going to write that down for you. I'm going to give it back to you, and I'm going to be able to transparently deserialize that into runtime types. I don't care about links in that moment, right? Like I like now, but to your point, I think the Brook version of LD files takes that one step farther and says, okay, but you really do care about links because you're going to change that data. And if you can give us some more meaningful boundaries around that stuff. And so I would say the boundaries come from application space. They should not be automatically inferred by WNFS. And my preference would be that the default is, some say in default that is probably like, I would just serialize and chunk the data and go, cool, this has a type that is LD file, and go, I don't know, it's always CBOR, done. Yeah, something really, really basic. Because as you said, you have to do like automatic merge semantics on that, and like it's gnarly. And so I would treat it like a file.
Right. Yeah. So like even the merge stuff, you can always ignore the merge and just say like every version of this I get, I'm not going to reuse structure. Right. It's just like I've broken the file up. I guess my question is, if you're not trying to do structural sharing over multiple versions, right, what's the advantage of understanding the JSON and breaking on a clean point as opposed to treating it like binary data and breaking? Because let's say I start incrementally reading in a JSON file, and I'm like, okay, I've discovered key value, garbage. Oh, there's another link in here. Let me grab that one. Oh, yeah, cool. Key value, right? Like, I agree that it's nice to not have to detect the garbage part, but like, is that the whole thing? Or is it like, is there more in there?
Yeah, I mean, the phrase that I've been using for this is semantic chunking, like chunking on semantic boundaries inside of the content type. And I'm with you that I don't see any. The only semantic chunking that makes any sense to me has to come from application space. The application has to define, these are the offsets that are going to matter. Trying to just automatically detect and align. I've taken a crack at that algorithm. You get weird shaped blocks. You get funny stuff. Like you can start throwing a Raven chunker at it, but like, I personally think there's very little value in treating data that hasn't been demarcated by an application for a specialized chunking strategy as anything other than serialized to bytes and chunk on a fixed size. Even go as far as to say a balanced DAG. Cool. Trickle DAG maybe, but like, yeah. That's my read on it. I personally see. I have yet to find any advantage of it, and we were like pretty obsessed with this back in the glory days because we're like, they're append-only CSV files. We should just be able to chunk on, and like they're parquet files, they're columnar. We should be able to just chunk on columns, right? And like, there was no the complexity that it imparted on the chunking really meant that the complexity also involved in doing the offsets that would then also be guaranteed to be semantic. Just force so much application space code down into the file system layer that the abstraction became meaningless. And so in my mind, it's if the application says, I am writing a thing called package.json, it has this key called dependencies, and each of those should just be CID links because that will give you something that looks a lot like Deno. Awesome. That needs to come from application space, in my humble opinion. So if WNFS had the faculties to be taught that, or for you to plug into the merge algorithm and say this, or to plug into the right chunker and say, no, thank you, I'm going to do the chunking for this type of file. Cool. But I personally think that's like wildly advanced, and I don't yet know if the benefit is actually there in contrast to. I mean, I think you could really make a strong case in like, as you said, very small changes to very large files that are structured data, which sounds like a database, but like, why are you putting a database in a file system? Why aren't you using something else?
We'll get to that. We'll get to that in one moment. Yeah.
Okay.
But yeah, like I agree that it's like this is advanced user mode for sure. having things automatic, like if we can do something sensible automatically, that would be ideal. It sounds like you've already taken a crack at that and it gets weird. Really good to know, like super good to know. Not surprising, but really good to know. I'm usually a fan, almost always a fan of building things up in layers and being like, here's maximum power, maximum pain, and here's a little bit less power, but like a nicer API, and above that, right? All the way up to like, this thing's completely automated and, like, but then you give people everything, all these layers below that. And I wonder if instead of forcing people to learn IPLD and like this, here's the trade-offs and here's the block size limits and like, having to learn all of this stuff to say, hey, you've got some JSON. Where do you want to break up? How many keys do you want in each chunk, right? Or whatever the API ends up being. Like there might be something in that design space. Not sure. Maybe not even useful, right? Like this is a really specific use case, which then brings me around to your last comment about databases. So I was on a call a couple days ago and explaining this to somebody who was like, "Oh, I didn't realize that like that's how this is going to work." So Dialog, which is our database that we're currently backing a spec out of a bunch of various proof of concepts about, and we'll be doing like a production implementation relatively soon. It needs to have some way of broadcasting this information. It's like, well, it's using the same data structures as WNFS, but we just shoved it inside of the same HAMT, right? There's, especially on the private side. So we can have public WNFS, public Dialog, and then this encrypted data structure that has, it's a pointer machine, right? You can have multiple different data structures inside of there. So we just shove everything into that. And you have to know where in the structure to look to get various roots of things, right? And because that has logarithmic height, it's actually putting lots of files in there is like not really a problem, right? So we can throw really granular small things in there and like lay the database data out in a smart way. And yeah, they work fairly differently, right? The performance characteristics are different. Things are pushed more to read time, all of this stuff, right? But having a deep integration with those two and saying, I want to express this as, over here, there's some large file, structured document, something. And over here, I have really granular data, like super granular data that's meant to be like highly concurrent and, that can take multiple different views of and query in different ways. There's some overlap in this design space, right? Which is like exactly JSON files of, here's a data store, and here's a query that interprets it as JSON, and it just knows how to do that because it's a JSON file. So that's another possible solution to this. But again, the performance characteristics are like pretty different because it's so granular. But this is a really long way of saying that like these are not totally separate worlds. They're going to live almost certainly 95% confidence. They'll live in the same data structure. And we can then leverage them with each other as we go. It's going to be mega rough on the HAMT sync. So tell me why.
Well, like, I think if I understand what you're saying correctly, you have lots and lots of little stuff chucking the HAMT. HAMT gets really big, lots of pointers inside of HAMT, and like the way that I understand synchronization is like often just like, cool, find entry point, pull from HAMT, pull from HAMT, pull from HAMT. But if you just do like a recursive, hey, pull everything in that HAMT, move it from here to over there, you now have the Filecoin problem, right? Where they have like this, they have CIDs that are longer than the blocks of the content that they point to for this massive HAMT. Versus in UnixFS world, when you create a directory that exceeds the size of a protobuf, you get a HAMT back as your response, and it just structures that as a hash array map try. So I agree with you that there's a ton of I don't think there's something to agree with her. Yeah, it's like the same problem, right? Like it's and so you could use the private HAMT or like a common HAMT or a commingled HAMT for that. You could also just generate a new HAMT the way the UnixFS does at every sort of juncture where you need that, and now the file you basically, which is in my mind, matches the mental model of like a database file at a specific path in a file system. It's like, cool, I'm traversing, and now I hit this big old HAMP that is much faster to mutate, much faster to access, to do like random access stuff. It's just like a better pattern for, and maybe what that arrives at is just LD files are just default HAMPs for as their mechanism. So you can chunk them up however you want, but well, you can't chunk them up however you want anymore. Now you need to be semantic about it. You need to go, okay, you need to encounter one of the compound data types if we're using JSON parlance as your top level. You don't need it, but you're only getting a single block if you use anything like null, true, false, whatever, any of the scalar data types. I could totally see LD files just always being HAMPs. And then you can optionally choose to merge those HAMPs as cool, there's already a HAMP lying around, chuck it in there. I don't think that's a big deal. The mutation of it, I mean, you lose a little bit of information, right? Like you lose, on sync, you lose like the CID of the root of the HAMPs, which is useful information, right?
Yeah, but you can also do things with symlinks instead of hard links, right? So you can say like,
okay.
over here, this path, right, or this name, right? All that stuff. Yeah. So
yeah, so you can keep that CID around and then just do cooler stuff with it.
Yeah. So this is actually one of the things.
But then you still need to build that. You still need to build that HAMP in isolation to get that CID.
You do, but if it's attached to the same overarching structure, then you have a path inside of that, right?
And you can just say, hey.
Yeah.
Right.
So the way we do everything is you have one top level immutable pointer and then names inside of that.
Right. Yeah. Right. And it's because of the naming system that allows you to sort of declaratively say, these are roots, right? Which is, I was thinking too generically about HAMPs and not specifically about the name filter HAMPs. Yeah. Okay.
Yeah. So like every link in there has like a name, right? You can go search inside of.
That's the phrase pointer machine. Yes. Yeah.
But yeah, so one of our open things to specify that we haven't actually done yet, and unfortunately Quinn's out today, otherwise I would have pulled her into this discussion too, because she'll see the video, is how to do serialization for all this data, right? So we have a pretty good idea of how to merge it, how to write it, all that stuff. But like when we actually go and write a billion of these things, are we merging blocks together? Are we keeping things really granular, like all of this stuff? And then that has to play against, if I'm doing a remote pull of data, I can't pull down a terabyte onto my phone. I wanted to be able to do like a really sparse selection, which may be difficult if I just have giant random, from the outside, random looking blocks of indeterminate size, right? So there's some work to be done there for sure. Anyway, getting off topic for WNFS, so it's like, the main point is like, there might be this interesting overlap. Since it's already in that data structure, maybe we make WNFS smart enough to know for JSON, lay it out this way that we have all these fancy tools for already. Maybe. So, yeah.
Yep. Could also use some of the like K-bucket, like weighted rendezvous hashing stuff for figuring out which block to put small pieces of data in.
Yeah.
That could be really cool.
That's interesting. Yeah, and then like up at the data layer, down at the data layer, it just looks like a concurrent write, from a WNFS point of view. It's actually not a bad idea. Yeah. Cool. Yeah. Just keeping an eye on the time. Fabrice, I did want to follow back up on the multiple views of data. I remember we talked about this in Iceland. I'd love to have it on recording and for the other people on the call. Could you expand on this idea?
So you were working up What?
Oh, sorry.
Yeah.
The idea of having multiple views of the data.
Oh yeah.
Could you expand on that?
Yeah. So what we're using in Capilloon as a data layer for all the user data, that can be media, that can be your contacts, that can be your navigation history, is we try to build something that can be used kind of like a mix of a file system and a database. So it's a bunch of resources. It's represented as a bunch of resources that are organized in a hierarchy. And on top of that, we do full text indexing of things that can be indexed. And so that let you search, and we do scoring based on how you visit your resources. And each resource, when it's a leaf, it can have multiple representations for the same resource. So you can see that a bit like a multi-mime object, where you have a primary representation. Like for a picture, it would be like the full resolution picture, but you would representation, and you could have an EXIF representation where you extract whatever characteristics about the image, and you can index that differently than the full image. So I think it's pretty powerful overall. It matches quite well what people do when they use a computing system. Is like they have documents, kind of, and resources are documents. So it's more like a document database with some hierarchy and text and so on. And so when I started to look at how to map that to WNFS, of course, yeah, there's this idea of how do we represent these multiple variants of a single resource, and because they are not just one file, and that's a very annoying limit with something like UnixFS, which is too basic to represent that. And so I have a few options, but yeah, I'm not sure exactly what I will use yet. LD links like that looks interesting. Again, yeah, I think I will know more if I can play with some implementation and see how it looks. On our side right now, we have fairly basic operations, like you can add variants to some very basic stuff. So it should be not too bad to map to various representations on the WNFS side. I could just go with like for each resource, I could create a subdirectory and store the different representation as files in that subdirectory, which is what my on this storage does right now, basically. That works. The issue with that is whether we want also to have like any regular WNFS client to have some at least some decent read-only access to your Capilloon data, even if you cannot do everything, but if you can at least have like read-only access of the main representation, it would be much nicer, and that informs us on how we want to go with the storage in WNFS. Yeah, I haven't decided anything yet. Yep.
Awesome. Yeah. Yeah. Super great. And something that is like related to some of the original design goals that we never like. Turns up with the file systems hard, right?
Yeah.
So you mentioned access control, like read only on like some of the variants. Is that you want like, let's say that I have a JSON, CBOR, and YAML representation of some file, but I only want to give somebody access to the JSON representation. Like, is that a use case?
Yeah, maybe. So what I'm implementing right now is that, like, if you store a picture in our system, I have transformers, and they will take this full size picture and create the thumbnail and do the extraction of like camera characteristics by themselves. So that means that you don't want people to modify directly the thumbnail or the EXIF extraction. you just want let them touch the full size representation if we want to update it. So there are things around that, yeah. It's not super high priority yet, but that will come at some point, yeah. It's more, I don't know, maybe it's more like locking some representations or, yeah. But the access control, if you consider that as more like me sharing something with you, I think it's a bit different. No, it's more, yeah. When we derive different representation from the main one, it's even like for the main user, you don't want the main user to touch just like a secondary representation of a resource manually. Yeah, it's a bit like database views in a way, but yeah, it's always a question about like, oh, I'm using a file system, but should I use just a database instead? Yeah.
Yeah, this is something we keep coming back to, is like, where exactly is the dividing line? And what we've really come down to is like, they're both data stores. They're just like slightly optimized for different use cases.
It's like knowledge representation and all that stuff. It's, yeah. I don't think there's one universal best way to do it. So once we choose one option, we have to make the best we can out of it and then see how to make forward progress on that. Yeah. You end up anyway, you always end up, I think you always end up needing blobs of some kind and metadata around your blobs and some nice ways to find them. That can be like, yeah, path traversal or full text indexing or some maybe more some, yeah, I just do full text indexing. It's pretty, and I have tags. So you can use tags as facets, which is kind of a different way to index. So yeah, hoping that with all that, we can build something that is good enough. And at least keeping in mind that the end goal is to help users find, well, make something useful of their data and build apps with that.
Yeah. Brendan down in the chat says, interesting in your use case that read-write permissions are totally independent of views. Brendan, is it just like a one-off comment, or do you want to like expand on that a little bit?
Just an observation. I put my random usings in chat to avoid bothering people.
Cool. Just wanted to make sure you had the space in the conversation to go into it if you needed. But yeah, no, it's
yeah, and on the implementation side, I started to look at the Rust implementation, and it looks like there's a very simple trait to implement, at least for the storage side. So I'm probably gonna hook that up to IRO, to the store side of IRO, and I need to hook up the other side to my virtual file system for the operations. But that doesn't look too complex. That's especially since I already have a bunch of hooks to listen for changes on resources, so I can just reuse these hooks that I used to trigger like more higher level events at the API level currently, but I can reuse that to update the storage on WNFS. So that's a good fit. Yeah.
Nice. Awesome. Well, that's my list at least. Does anybody else want to chat about anything else, or should I give you all the last 13 minutes back here?
Can we go back to the scary cryptographic accumulator change question and
sure.
and the implications for that? Because making them 5 times larger, I've seen those things. They're pretty big. Multiplying that number by 5 is a little bit sketchy. Yeah, not to be a downer, but like any way we can help? Actually, let's not be down. Let's be constructive. Is there any way I can help with the? I too am not a cryptographer, but I think could you help, Brooke, just by like identifying in more concrete terms, like what the specific security vector threat is with the accumulator being as small as it is right now?
Yeah. So I guess a couple things. Before I get into the like increasing the size version, which is like I agree, it's my least favorite solution to this problem as well. As an example, most elliptic curve accumulators are 32 bytes, right? The accumulator itself. And so they end up being very, very small. Technically speaking, a Merkle tree is also a cryptographic accumulator. The problem is that the proofs depend on are quite long. You've got to give the entire path, right? But the actual name filter, scare quotes, in that version is a Merkle tree. It's a Merkle root, right? And so that's very small. It's the size of a hash. So size is one dimension that we can move along this to increase to solve this problem I'm about to explain. So in the current version, there's basically two related problems. They're really the same problem, but one is being a Bloom filter. You have a 1 in a billion collision chance, and so you could potentially 1 in a billion files you could write to a path that you're not allowed to write to, right? So it's really the main problem. And then one way of trying to solve that is to increase the size of the Bloom filter so that you have 128 bits of security, right? So you just make it much, much bigger. I don't love that version. I also don't love the the Merkle tree version because the proofs now, so if you want to prove that you're allowed to write into a certain area, that proof is enormous all of a sudden, right? You have to give all the siblings, and the smallest you can make it is a binary tree. And so you have some, log of the number of elements in the tree, and they don't extend very well. So you have to give the prover, so the person writing, they have to see all the elements inside of the Merkle tree to construct a new one with more elements, right? There are ways around that, but that's basically it, right? With some of these other techniques, the more basic RSA accumulator or elliptic curve accumulators use the same, basically the same technique that you use. RSA is something we're all familiar with, right? It's, you have some exponentiation and then you're doing multiplications on that. So you also get these nice properties like the order doesn't matter and, all of these things. That works really, really well. The downside is that it has every version that seems to have some other trade-off, like the elliptic curve one, the really basic elliptic curve one we looked at blew through all the memory and crashed node, right? The RSA ones have really big on the same order of magnitude as a name filter keys. And often you need to, actually I think in RSA, you don't need to know all of the elements. You can just keep appending stuff to it, which is actually really nice, right? So it's like, we haven't even ruled out RSA here. They're slower. They're definitely slower. And the proofs also end up being not as big as a Merkle tree, but bigger than we would hope to get them, or the witnesses, I should say. There's some newer work out of Oracle Labs using vector commitments. So instead of using a Merkle tree, use a Verkle tree, which lets you say, here's an array of elements, and at this, without knowing all the rest of them, at this index, this element exists. And so your proof is just essentially like an index offset and saying this element is in here and here's some extra cryptographic material. I can prove that this is in the commitment. contact, right? That math is pretty hairy, and as far as I can tell, there's no implementation of this. This work was done for Filecoin, so it might be inside of Filecoin, but nobody can point me at the relevant code, right? So I think it probably hasn't been implemented yet, as far as I can tell. I've asked Nicola, who's a co-author on the paper. I haven't heard back, so which is fine. I'm sure very busy, right? But yeah, I don't think that there's an implementation. Oh yeah, thanks, Brendan. Yeah, if you could ask people, that would be helpful. Yeah, so we actually started poking around for like maybe we could use a vertical tree, and then we bumped into this paper they wrote 2 years ago. I'm like, okay, they're thinking about it, but if we do an implementation of it, we need to get it audited. If there's an existing implementation, we will happily use it, right? So it's sort of the thing. There's also, and again, I haven't seen an implementation of this. There's another paper that uses ZKPs. Well, I guess all of these are technically some variant zero knowledge proof. They use snarks to solve this problem. Snarks obviously have some, have various other trade-offs, but that's another thing that we, in theory, could do. Yeah, it's just like in the exact portion of the design space that we're in, where we don't want to reveal all the elements. That's another dimension that we could relax, right? Where you would then see essentially, like maybe it's out of order or something, but you'd see the file path that you're at. And we don't want to give everybody read access to their file path. If you're only given some deep path read access, you don't want to know like, this is inside of all these other things, right? And then you start correlating parts of the tree. But this is all to say, we haven't dug into this for like days and days and days. This is like, Philip and I working like off the side of our desks while we wrap up a couple of things, then we're going to look at it in earnest. The short answer is that there might just be something that we haven't seen yet. I did talk to a couple of people inside of PL who did get back to me. And most of them pointed me at the ECC-ACC library that doesn't perform for our use case, like not even close. And I think at least one of them said, like, from a quick Google, this is what comes up. I'm like, yeah, I know. I've played with this one. And then, yeah, another person basically said, like, yeah, they keep looking at them. They always have trade-offs that they're not happy with. It keeps coming up because they seem really, like, really promising, but you really have to figure out like what you're willing to trade off. Okay, so this is like matching exactly our experience. But even, let's say we do the RSA version of it, in fact that RSA, keep needing to get bigger and bigger and bigger keys for it, isn't out of the question, super well understood cryptography. I've done the RSA accumulator by hand with a small key just to understand how it's done. Super straightforward. Actually, the elliptic curve one, the basic one with the n squared prover time. Also super simple, right? It's like really basic operations. Yeah. So they're not out of the question. We just haven't done this like haven't decided on the exact direction. It's just like currently a small corner of research that we're going to expand into in the next couple of weeks. And if anything, hopefully we make those name filters smaller, right? So today, for those on the call that aren't aware, we have this relatively large, 2K, well, kilobits, not bytes, name filter, like Bloom filter, and then we hash it, and we use that inside the HAMT, and then we post that on the outside, like in clear text, like this associates to that hash. I would love to do away with that completely, and just, the position in the HAMT is the accumulator because it's equivalent to hash in terms of entropy, right? Yeah, but we'll see what comes out of this, right? So,
totally.
Yeah.
Cool. That's really helpful. I appreciate the brain dump. I'm going to go back and play this video slower. Get my running around some of
Yeah.
the. No, it's all good. It's nice to see some of the paths that you're looking down. Cool.
Yeah.
Maybe I can help by just like running some human resources down.
Yeah, absolutely would be super helpful. Yeah, and I talked to Dig about this as well a couple weeks ago, who pointed me out a few people in TypePL.
Okay.
Yeah, so the main person I would love to pick their brain would be Nicola, but I also realized that Nicola has like 50 million things going on at any given time. So yeah.
Cool.
Awesome.
Thanks so much for putting together this call.
Thanks. Well, thanks everyone for showing up to it and participating in the discussion.
Thank you, Brooke.
Thanks. Awesome. Well, I don't know about all of you, but I'm gonna go and watch what I'm gonna buy from Apple in the next hour. So.
Amazing. Have a good one, everybody.
Thank you. Well, bye-bye.